Our last lesson has no new material. It just is going to be about making decisions about which of our formulas to use. So have your solving triangles problem set out, and what I'm going to do is talk you through how to choose and get your problems started, and I'll expect you to finish them on your own. So we have three laws. First, there's a law of cosines, and you can copy the formula right off your formula sheet. You don't need to memorize it. And you use the law of cosines when you have a lot of side information but not much angle information. In fact, the most angles you could have would be 1. Our second law is the law of sines, also on your formula sheet, no need to memorize. You can copy it off of your formula sheet if you'd like another place to have it written down or just to practice writing it. And we use our law of sines when we have more angle information than we do side information. We also use the law of sines when you're asked those ambiguous case problems, the how many triangles questions. The last law we learned was area of a triangle, area of any triangle. And with those problems, you just need to read about area. When you are asked for area or given an area, you use the area formula. Okay, so getting started with working through some of these problems. And again, I'm just going to start them for you and have you finish them on your own. So we have a man standing on a cliff that's 80 feet high, 85 feet high. He's at the edge of the water and he sees two ships. He positions himself so that the ships are in a straight line with 2 points directly below where he is standing. So that's telling you that you can assume that cliff is perpendicular. He estimates that the angle of depression of the closer ship is 75 degrees, and the angle of depression of the farther ship is 35 degrees. We want to, in the end, find out how far apart the two ships are. Angle of depression is if you're standing up high and looking at something down low, like a man standing on a cliff looking at ships out at sea. It's how your head moves down from its starting position, which is usually parallel to the ground. So I've labeled the picture for you. We're looking for the distance between the ships. I have a lot of angle information. Looking for a side. Looks like I'm going to use a law of sines. Remember also, as you try to complete this problem, that sometimes it's helpful to break up the pictures into separate triangles. Also remember that parallel lines cut by a transversal form congruent alternate interior angles. So you have even more angle information than it seems that you're given at first in this problem. So again, you're labeling lots and lots of angles. You're going to use the law of sines. The next triangle, or the next problem, you're given triangle ABC. Side AB is 24, AC is 40, and the measure of angle A, sorry, I'm having a hard time reading, is 30 degrees. Find the area. Well, you just use your area formula. And like any other formula, you rearrange it to match what you're given. So we'll use the area formula as 1/2 BC sine A. Now, for part B, you're asked to find the length of the altitude from point C to side AB. That you would have to draw in a separate line, and I'm going to have you try that entirely on your own. And we can come back to that as a bonus style question. For number 3, we're talking about the perimeter of a rectangular park and that being fenced in. The lengths of each side of the fence are 76, 84, and 94. You're going to find the measure of the smallest angle of the park to the nearest degree. Lots of sides, means law of cosines. You're looking for the smallest angle, which is opposite the shortest side. So lots of sides, looking for an angle, that's our law of cosines. When they don't label a triangle for me, I use ABC in the order it's given on the formula sheet. Finally, we have number 4, Coast Guard Station A is 12 miles west of Coast Guard Station B along a straight coastline. A ship is sighted by the crew at Station A to the northeast of the station at an angle of 35 degrees of the coastline. So you can draw that in. And by the crew at Station B to the northwest of the station at an angle of 46 degrees with the coastline, or 8. Angles of a triangle add up to 180, so you can get that third side. We want to find the distance between the two ships. We have lots of angle information. We'll use the law of sines. So again, I've set these problems up for you and gotten them started. You need to finish them on your own. We'll go over them in class. And finally, just to summarize one more time, when you're deciding which law to use, lots of angles, law of sines, lots of sides, law of cosines, area is area. And also, just a reminder that most problems will require more than one law or step. You're in Algebra 2, Advanced Algebra, Trig, that means more than one step. And that's all for today. That's all for this unit. Have a great night.